Welcome to The Explainer. We've all been caught up in the incredible hype around AI, but what if it's all just a clever illusion? Today, we're digging into two expert perspectives, one from AI pioneer Yann LeCun and another from researchers Coveney and Highfield, who argue that the real future of AI, well, it looks nothing like its present. So let's just kick things off with this incredibly blunt statement from Yann LeCun, one of the godfathers of deep learning. He thinks we're being fooled by today's AI. And what's really fascinating is that a brand new scientific paper is saying the exact same thing, but for a totally different reason. And that's where things get really interesting. And it's easy to see why we might be fooled. I mean, just look at what these models can do. They write beautiful poetry. They can generate complex code. They can even pass the bar exam. They seem to have this mastery of language that feels so intelligent, almost human. But this is the big question, isn't it? Are we just mistaken fluency for actual understanding? Both LeCun and that paper from Coveney and Highfield are warning us that we're seeing illusions of intelligence. What looks like pure brilliance is actually a very, very sophisticated form of mimicry, and the cracks are definitely starting to show. So if it's an illusion, we have to ask why. What are the fundamental flaws that are holding AI back from true intelligence? Let's take a look at the cracks in the code. Okay, so this gets right to the heart of the problem. Today's AI is an absolute master at matching patterns. It's analyzed trillions of words, so it can predict the next word in a sentence with incredible accuracy. But, and this is a huge but, it has zero real-world understanding. It doesn't know that a pen you drop will fall. It only knows that the word fall often comes after the words drop a pen. That distinction is absolutely crucial. And look, this isn't just a theory. This lack of understanding has real-world consequences. Researchers gave an AI all the data on planetary orbits, the very same data that Kepler and Newton used. But the AI couldn't figure out the laws of physics. Instead of discovering gravity, it just found a bunch of statistical shortcuts that produced, and I'm quoting the authors here, nonsense. So the missing piece is what scientists call a world model. This is something we humans start building practically from birth. By just 9 months old, a baby gets that an object is still there even when you hide it. It's that intuitive grasp of physics, and that's what AI is completely missing. Now, the obvious answer seems to be, we'll just give it more data, right? But it turns out, just scaling up the data is not the solution. Actually, that approach creates a whole new set of massive problems. The research from Coveney and Highfield is pretty damning on this point. Bigger datasets can bake in what they call distributional failures, like healthcare algorithms that just don't work as well for certain groups because the training data was skewed. They also drown the AI in meaningless correlations and risk this scary feedback loop where AI trained on AI-generated data just gets dumber and dumber. This is the classic example of what's called a spurious correlation. We know that a third thing, hot summer weather, is the real cause. But an AI, swimming in all that data, it can't tell the difference. It might actually conclude that selling ice cream causes shark attacks because it can't reason about the underlying physical world. Yann LeCun really drives this point home with a fantastic example. A teenager learns to drive in about 20 hours, with maybe a few close calls, but probably no crashes. For an AI to learn the same way, using the same methods, it would have to crash itself thousands of times. It's just not a viable path to real-world intelligence. Okay, so if the current approach is basically a dead end, what's the alternative? This brings us to the blueprints for the future. And first up is Yann LeCun's idea we need to teach AI to learn from reality itself. LeCun argues that AI needs to learn just like this baby, not by reading text, but by actually observing the world through sensory data, like video. It needs to watch, predict what's going to happen next, and slowly, piece by piece, build up that internal world model of intuitive physics that we all just take for granted. And this is where it gets absolutely mind-blowing. LeCun did the math, and by age 4, a child has processed about the same amount of data as a large language model. But here's the kicker. The child's data is this rich, multi-sensory, real-world information, not just a bunch of text. It proves the key isn't the quantity of data, it's the quality of the data. So this vision is what's driving LeCun's work on new architectures like JPA. Instead of making the AI predict every single pixel in the next frame of a video, which is practically impossible, JPA learns to predict the abstract idea of what will happen next. It's a fundamental shift and a huge step towards building a true world model. Now, Coveney and Highfield propose a second but complementary blueprint, and their idea is just as radical. What if, instead of just teaching AI the laws of physics, we build those laws directly into the AI itself? They call this vision big AI. So unlike a pure AI, which is basically a black box, a physics-informed AI is interpretable because it's grounded in principles we already know and understand. This means it's way better at handling uncertainty, it has actual insight into how things work, and, this is huge, it's far less dependent on those massive, flawed datasets. And the advantages here are just enormous. By embedding laws like the conservation of energy, you stop the AI from making physically impossible, nonsense predictions. It becomes a system you can actually trust, one you can audit, which is absolutely essential if you want to use AI for high-stakes things like designing new medicines or creating new materials. So what does this all mean for the future? Well, the clear takeaway from both of these perspectives is that the next AI revolution is not going to come from just building bigger and bigger models. It's going to come from fundamentally changing how they learn and what they know about the world. The Coveney and Highfield paper even lays out a potential roadmap. And it is a long-term vision, for sure. It starts with new physics-informed algorithms, then moves to hybrid and quantum-inspired computers, and eventually grounds AI in the next generation of computing. Which leaves us with this final, fascinating question. The whole future of AI really hinges on this choice. Do we chase LeCun's vision of a machine that learns physics like a child? Or do we go for Coveney and Highfield's vision of a machine built with the laws of nature embedded in its very code? The answer is probably going to be a bit of both, and it's what will define the next era of intelligence.